Algebra 1, Chapter 1, Section 4, Solving Multi-Step Equations. Oh, I didn't want to do that. So let's draw a little kind of an irregular triangle here, so it may not necessarily, yeah, that'll work right there. And let's label these vertices as 50 degrees here. We're going to call the top vertice x plus 10, and the bottom right vertice is going to be x plus 20. So we know that all of the angles in a triangle add up to be 180 degrees. So if I took x plus 10 plus x plus 20 plus 50, all of those total together would be 180 degrees. So I would say take a minute to pause right here and see if you can combine like terms and solve for x. And in a moment, I will be back to do that after you have hit play again. So let's look at all the like terms. I have variables there. I have numbers there, and I'm looking at the like terms on the left side. And so let's put all those like terms together. 1x plus 1x is going to give me 2x. And then 10 plus 20 is 30. 30 plus 50 is 80. So my equation is 2x plus 80 equals 180. So now I know I have to get rid of two things to get I have to get rid of two things around the x, the 80 and the 2. That's what makes it multi-step. And so the question is, which one do I do first? I always take the one that's not attached to the x first. And in this case, that's what you have to do first. You take that positive 80, you balance it to the other side by doing the opposite of addition, which is subtraction. Those will cancel, leaving me 2x equals 100. And this is just like our section before. This is a multiplication problem, so I'm going to do the opposite, which is divide, and x comes out to be 50 degrees. Now, if they ask you what x is, you are done at this point. If they ask you to put it back in, then that top angle is going to be x plus 10, which is going to be 50 plus 10, which is 60. And the bottom one is x plus 20, which is 50 plus 20, which is 70. And you should do a quick check just to make sure that 50 plus 60 plus 70 does actually come out to be 180. And 50 plus 60 is 110. 110 plus 170 is 180. And so that checks. So x equals 50. Again, multi-step, very similar to Chapter 1, Section 3. So what can they do? Maybe they can throw some distributive property in there. We might have something that looks like this. Two parentheses 1 minus x plus 3 equals negative 8. So please excuse my dear Aunt Sally, says I need to do the parentheses first. So I'm going to distribute. I like to call these my stupid arrows because that tells me that I have to multiply everything on the outside by everything on the inside. And after a while, you will hate to draw them, and you'll keep asking me, Mr. No, do I have to draw those stupid arrows? So I just went ahead and labeled them stupid arrows, in my opinion. And so, yes, you are going to have to draw them every time you have a distributive property problem. So in this case, 2 times 1 is 2. 2 times negative x is going to give me negative 2x. And then I have the plus 3 on the outside equals negative 8. Now I want to identify my like terms. You don't have to highlight these. I'm just doing it for my purposes. I want to identify my numbers. Doesn't look good if that one's big and that one's not. So I'm going to put those together. That's going to give me 5 minus 2x equals negative 8. Now here's a question. I need to move the 5. I need to move the negative 2 that's in front of the x. It's connected, so I know I have to move the 5 first. My value of 5 is positive. So to get that positive 5 to balance to the other side, I need to subtract it. And so that gives me a negative 2x equals, and then when I take negative 8 minus 5, that's going to give me negative 13. Negative 13. And then I'm going to divide both sides by negative 2. And if I have a negative divided by a negative, that's a positive 13 over 2. You are welcome to leave it as 13 over 2. You could change it into 6 1/2, but do not change it to a decimal. I know there are some examples in the book that change it to decimals, but I prefer in algebra that we look at them as fractions. And that gives us another way to work on some fractions as well. So there's some distributive property. How about, let's do one more example. How about something like, how about something like that? That's got a lot of stuff going on. And so I'm going to consider that 2x minus 6 is on the top, and that's kind of connected to the x. So I'm going to get rid of the 4 first. And it's actually, if you did PEMDAS backwards, not PEMDAS backwards, because that would be addition, subtraction would be then. No. Ignore what I just said. So the 4 is not connected to the x in any way. So I'm going to multiply both sides by 4. That's going to give me 2x minus 6, because these 4's are going to cancel, equals 40. Again, the 2 is connected to the x, so I'm getting it last. The opposite operation of subtraction is addition. So that gives me 2x, after those cancel, equals 46. Divide both sides by 2. And x is going to end up being 23. So knowing what steps and when to do them is very important. Take the number that's connected to the x last. Move everything else that's further away first. And that is Chapter 1, Section 4, Solving Multi-Step Equations.